The Lancers, or Columbias as they're known today, or now Corvallis, are a composite aircraft, yes, but there's extensive use of carbon fiber in the aircraft. Wherever there's structural strength on this aircraft, it's carbon fiber. So for example, the wing is a one-piece wing, and it's not two wings that join together. The wing is made totally separate of the aircraft, and it has not one but two carbon fiber spars in it that run from wingtip to wingtip. So liken it like you're sitting on two steel I-beams. That wing has been stressed to over 18.5 Gs, and it will hold up to 25,000 pounds. In fact, one year at Oshkosh, we took the wing separate of the aircraft, put it across two concrete barriers, and put a Ford Excursion on top of it, and we could have put two more Ford Excursions on top of it. That's how strong this wing is. All of the control surfaces on the Lancer and the Columbia aircraft are carbon fiber. So your ailerons, your flaps, your horizontal stabilizer, your rudder, your elevators are all 100% carbon fiber. So the plane is built tough. You'll also notice the hardware. The hardware on this aircraft is all high quality anodized or cast aluminum hardware, and there's multiple attach points for all of your surfaces. So you have 3 hinge points for your ailerons, 4 for your flaps, a piano hinge for your elevators, so there's no place for a single point failure. Another huge feature of the Lancers is that the Lancers have no springs, cables, and pulleys in the aircraft. You are directly linked to your ailerons and your elevators by lifetime pushrod controls that are operated by the dual joysticks in the aircraft. So when you're flying this aircraft, you're flying the real McCoy. You're feeling the real air pressures on your control surfaces instead of going against spring tension as you'll find in springs, cables, and pulleys. As I mentioned previously, the Lancers were certified to be spin resistant. And they did that in several manners, but they worked with NASA on the A-Gate program, and they designed this wing cuff, if you will. And what this wing cuff allows you to do is that when you're in a deep stall with the aircraft, you'll stall the root area of your wing first, but you'll have this wing cuff out here that's at sort of a negative angle of attack or camber, if you will, and so this wing cuff out on the tip of your wing will continue to fly. So now you've got your fulcrum point way out on your wing. The other features on the aircraft is it also has what's called a rudder limiter, and so if you're on a power-on type stall, the critical bank, if you will, for the aircraft is to the left. And so you don't want to kick too much left rudder if you're in a critical bank. And so what they do is they will have a rudder limiter that will kick in if you have manifold pressure on, your stall alarm on, that will limit the travel or the throw, if you will, of your left rudder to from about 20 degrees down to about 12 degrees, and won't give you what it would take to kick the plane over. That being said, the aircraft once again, is FAA certified spin resistant, but it's been through all of the spin testing as well. It's really hard to get one of these aircraft into a spin, and it's not very hard to get it out if you were able to get it into a spin. The Lancers are equipped with the Hartzell 3-bladed prop. The 3-bladed prop is a great combination of climb performance and speed, and the Hartzell name has a great reputation out there. The nose wheels on the Lancer, Columbias, and Corvallises, you'll notice, have no cables attached to it, no shimmy dampeners attached to it. It's a very clean, free castering nose wheel. And the way we take care of it's a heavy-duty nitrogen-loaded strut, because you have that heavy engine on there, and if you have not so perfect landings and whatnot, the front end of this aircraft can take a huge beating. It's very easy for the line fellows to tow it around and push it forward and back. The wheel's not going to kick out on you and whatnot. And we take care of our shimmy dampening by that nitrogen-loaded strut is mounted in a oil bath tube with baffles in it, and that baffling takes care of your shimmy dampening. The fuel system, if you will, or capacity on the Lancer is 98 gallons of usable fuel. So when you figure a rich of peak, you're burning about 17.5 gallons an hour. You can see that you got quite a range on it. If you wanted economy mode, as I mentioned earlier, you could pull this thing back to say 12.7 gallons an hour down low, and it'll go, like I said, way beyond what your bladder will be able to hold. Useful load on these aircraft are well over 1,000+ pounds on the Lancers in general. And if you go high, the certified ceiling's 18,000 feet on the aircraft. You can literally get your fuel burn down to 9.5 gallons an hour, and once again get a huge range with the aircraft. The beauty of the Lancer 300s, where everybody talks about the glass cockpits and whatnot on the aircraft, and yes, this is a 6-pack, if you will, where it has a standard gauges, so it doesn't have the primary flight display. But if you start looking around the cockpit and whatnot, you'll see, yes, your radios are separate, but you have half the glass here. You have the, and we'll get to that, you have the dual MX-20s on the aircraft in that regard. But before I get into that, the beauty of the aircraft, if you start to the left over here, you'll see that we have all of our analog engine gauges here. We have our left and right fuel quantities and the indicator lights that tell you what you have. You have 49 gallons, I'm sorry, of usable fuel on each side. You have your vacuum, pump or vacuum gauge. This plane has not one but 2 vacuum pumps in it, and the only air-operated instrument in the aircraft is actually your attitude indicator. And in the event that you had so you have a lot of redundancy built up in that regard. Oil temperature and oil pressure, manifold pressure and your fuel flow are in this gauge here, and then you've got your RPM right here, very easy to look at. This aircraft is equipped with a JPI EDM 700 engine analyzer, which is extremely useful in seeing what's going on with each one of your cylinders. So you'll have CHT, you'll have your EGT, you have your lean find. You'll have, it goes through everything you need to see as far as that's concerned, and then when you're in flight, it continually rolls through each one of the cylinders. Up here you have a Davtron clock, and your outside air temperature shows up on here as well, so you don't have any big probes sticking out of the sleek aircraft.